In this video, we are going to do a profit maximization question. So this example comes from our final practice problems part 2, and it's question number 12. So I want to begin by giving you the opportunity to try this question. So I want you to pause the video for at least 7 minutes to try this question. These max-min problems can be longer, so more time this time. So 4, 3, 2, 1, pause the video. Pause it for 7 minutes to really try this question. Treat it like an actual exam. Do this in a distraction-free environment, hopefully, and then see how well you're able to set this up and make progress with solving this question. All right, so hopefully you've done that. Hopefully you've paused it for about 7 minutes to try it. Let's start to talk about it together now. All right, so part A asks us to form a function that gives your profit as a function of x and y. And I'm going to assume that you've gone ahead and read the question, so I'm not going to read it together just for the sake of time here and get into solving this. So we want to write the profit, and the profit is equal to the revenue minus the cost. So I need to get the revenue and the cost. So let's begin with the revenue. And in this question, there are cheaper units being sold and there are deluxe units being sold. So to find the revenue, I have to consider the revenue from both types. So let's do cheaper first. So that would give me, I need to know the price times the quantity. So I need the price of the cheaper unit times the quantity of the cheaper unit. And then I have to add that to price times quantity for the deluxe unit. So add that to the price of the deluxe unit times the quantity of the deluxe unit. All right, now let's start to plug in for these values. So first, I need to know the price of the cheaper unit. So it says the cheaper units are sold at price P, and here is a formula for what P is. So let's plug that in. We get 24 minus 0.05x minus 0.1y. And then next we need the quantity of the cheaper unit. And the question says that x is the number of cheaper units sold. So the quantity is x for the cheaper unit. All right, and then plus price of the deluxe unit. And the question says that the deluxe units are sold at price Q, and Q is given by this equation. So we'll plug in 70 minus 0.1x minus 0.4y, and then times the quantity of the deluxe units. And the question says that y is the number of deluxe units. So y is that quantity. And I could simplify this. So let's distribute x and y. That gives me 24x minus 0.05x squared minus 0.1xy. And then plus 70y minus 0.1xy minus 0.4y squared. All right. So there are a couple of like terms that I can combine. There are these two xy terms that I can combine. So the rest stays the same. 24x minus 0.05x squared. Now I combine those two terms to get minus 0.2xy. Let's underline it so I know that those are the ones I combine to get this. Plus 70y minus 0.4y squared. Let's write that squared better. Okay, so we have our revenue. So we are ready for our cost function now. Okay, so the cost is being described in this sentence that says, here are your costs for your business. 400 for each cheaper device, 1,000 for each deluxe one, plus $50,000 of fixed costs. Okay, so one thing to keep in mind in this question is it said that our prices and everything were in hundreds of dollars. So I'm going to keep that in mind when I write costs as well. I'm going to write them in hundreds of dollars. Okay, so for the costs of the cheaper items, I'm going to have to multiply 4 times the number of cheaper items, which was X. Notice I'm writing 4 because I'm keeping in mind that the units are in hundreds. Units are in hundreds of dollars. And then I would add that to the 1,000, which I'll write in hundreds as 10, times the number of deluxe units, which is Y. And then I have to add on the fixed cost to this. So 50,000, if I write that in hundreds, is 500. It's 500, and that's 50,000. All right, so this is showing up here because the fixed costs are the costs when I sell 0 items. So when X is 0 and Y is 0, the cost needs to be 500, and that's in hundreds of dollars. So that's why that needs to be there. All right, so we have our cost function, we have our revenue function, so we are ready to write down the profit. Profit is going to be the revenue, which is 24x minus 0.05 x squared minus 0.2 xy plus 70y minus 0.4 y squared minus the cost function, so minus 4x plus 10y plus 500. So next I would distribute the negative and combine some like terms. So that'll give us the 24x minus 4x gives us 20x minus 0.05 x squared minus 0.2 xy. And then we get 70y minus 10y, which is plus 60y. And then there's minus 0.4 y squared. And then finally we have the minus 500. And that's what part A asks for. It asks us to just set up that profit function. Okay, and then part B of this question asks us to find the price of each type of device that yields the maximum profit. All right. So we got to begin that process by finding the critical points. So we have this multivariable function. I got to find the critical points. So let's take some partial derivatives. Partial with respect to x, set that equal to 0. And with respect to y, set that equal to 0. So if I take the partial with respect to x of the first term, I get 20. For the next term, I'll get minus 0.1x when the 2 comes down. For the third term, I'll get minus 0.2y. And the remaining 3 terms all give me 0 because none of them has an x in it. And then that's equal to 0. If I do the same thing for y, the first 2 terms end up going away because neither has a y. The third term gives me minus 0.2x. Fourth term gives me plus 60. Fifth term gives me minus 0.8y. And the last term goes away. And that equals 0. So I have a system of equations, and I'm going to start to solve this. All right, so here is my system one more time. In the second equation, I just moved 2 of the terms around, so I could have all the constants in front, and then the x terms, and then the y terms, kind of lined up nicely. So when I have linear equations like this, we can use elimination to help solve them. We could also do it by substitution, but elimination just works pretty nicely. So I'm going to multiply the first equation by negative 2. And that will give me negative 40 plus 0.2x plus 0.4y equals 0. And that's nice because if I write down the second equation, minus 0.2x minus 0.8y equals 0, now when I add them, the x terms are going to cancel. And that's kind of the end goal when we do elimination. Elimination involves either adding equations or subtracting them so that one of the variables cancels away like this. Okay, so I get 20 in the front, And then we have a minus 0.4y equals 0. So this gives me 20 minus 2/5 y equals 0. And if I rearrange, this is 20 equals 2/5 y. And now isolating y, we get y equals 20 times 5/2. And I could simplify, I could divide the 20 by 2 to leave me with a 10 up here and a 1 down there. So I get y equals 50. So now I have my y value. I'm going to plug it into one of my equations. I can plug into either equation to find x. Okay, so I'm just going to plug into the first equation. So I'll get 20 minus 0.1x minus 0.2 times y, which is 50, equals 0. And this becomes 20 minus, and then 0.2 times 50 is going to give me 10. And if I move the x term to the right, we get equals positive 0.1x. So this gives me 10 equals 1 over 10x. And then isolating x, we get x equals 10 times 10, which is 100. All right, so I have my x value. So we can write down our critical point. So our critical point here, the x-coordinate is 100, and the y-coordinate is 50. Okay, but I need to see if I have a max or a min at this critical point. So we need to now, test our critical point using the second derivative test. And that's how we'll verify whether we have a max or a min here. We're hoping it's a max because we wanted to maximize the profit. Okay, so recall what our partial derivatives were. So now, let's recall our formula for h, the Hessian. So it was pxx, because this time our function is p instead of f. Pxx times pyy minus pxy squared. So h equals. So for pxx, I look at px, and I take the partial with respect to x, which is negative 0.1. For pyy, I look at py, and take the partial with respect to y, which is negative 0.8. And then for pxy, I look at px, and then I take the partial of that with respect to y, which is negative 0.2. And then I have to square that. So simplifying this, we end up with first two terms multiplied is 0.08. And then I get minus 0.04, which equals 0.04. So that's positive. All right, so that is positive. So we can now say that since h is greater than 0, and then we need to look at pxx. Pxx is less than 0. We will have a max. That's what the second derivative test says in this case. Okay, so the final thing to do is make sure we answer what the question ultimately wanted. And the question ultimately wanted to find the price of each type of device. That gives us this max profit. So we need to find the prices. Find the prices. Okay, so we have a formula for P and for Q for those two prices. For P, the formula was 24 minus 0.05 times X, so I'll leave a space, minus 0.1 times Y, and I'll leave a space. And for Q, it was 70 minus 0.1 times x minus 0.4 times y. So remember, x was 100 and y was 50. And if we work out both of these values, p ends up being 14 and q ends up being 40. All right, so I just need to write a concluding sentence now. So I would say something like, the profit is maximized when P is the price of the cheaper unit, when the cheaper unit costs 14, and remember, P and Q are in hundreds of dollars, so it's $1,400. And the deluxe unit costs, it's $4,000, which is $4,000. And that's our answer.